Hey guys, in this video we're going to add an enemy that will follow the player around, and when he collides with the player he'll periodically damage the player. So first, before we get started on the enemy, I want to go ahead and delete this wall that I added to the main scene. So I have the main scene open here. Just select it, right click and delete, or alternatively you can just select it, press delete, and then it's going to confirm. Okay, so in the main scene right now all we have is a player. First, I want to define an enemy. So let's go ahead and create a new scene for an enemy. So again, you've noticed that every concept, like game object that I can think of, like player or bullet or enemy, I create a scene to represent it. And I usually, as you know, I put as the root of the scene a 2D scene, 2D node. All right, so let's save this right now and just call it enemy, I guess. All right, and now let's give it a child node. Let's give it a sprite, and let's go ahead and give it a graphic. I'm gonna, because I'm lazy, I don't want to import an enemy right now, so I'm just gonna give it this this thing right here, this icon. So all right, so our enemy will look like this for now. Let's also add a area 2D, because we need to know when the enemy collides with the player. So we're gonna add an area 2D and give a collision shape child to the area 2D. And let's give an actual collision shape here. So I'm gonna choose rectangular because that's what that looks like. And let's make sure that the collision shape encompasses the entire graphic for the enemy. Okay, let's add a script to the enemy. So select its root node, click this button here, and choose C# and call it enemy.cs. Click create. As you know, I use VS Code to do all my code editing. So let me just open that up. Here it is. And let's open up enemy.cs. Let me zoom in. Let's delete all of this template generated code. All right, and now the plan is we want the enemy to keep on following the player. So we're gonna make an assumption here. We're gonna assume that whatever scene the enemy is in, and the enemy is gonna be in the main scene. So in the main scene, this is where we're gonna have everything. This is like our world, right? The root in the main scene is also gonna be a node 2D, that generic node. But as its child, it has a player, right? Which is this guy here. I don't know why his name is player. Yeah, so let's rename that. I found a little bug here, so just click to rename this. This is player. Okay, so in the main scene, we have the player, but we're also gonna have here all the enemies. So what we're saying is that the enemy and the player will have the same parent, right? They'll be in the same scene. So that's an assumption that we're making with the enemy. So what we want the enemy to do is get a reference to the player. And you know that you can use the getNode method to get a reference to any other node in the tree. So we'll use that to get a reference to the player, and then we're going to keep moving towards that player in our process method. Now we've done this 2 times before. We moved the player in the process method in response to keyboard keys, and we moved the bullet just forward in its process method. So you'll see that we'll do something similar here. So let me go ahead, write this code real quick, and then I'll explain it to you. All right, so here's the code. First, we use the getNode method to get a reference to the player. And look at this path syntax here. When you do ... it means go up 1 level. So go to the parent node and then go to player. So again, let's go look at the main scene. We're gonna assume that the enemy is gonna be right here under the player, right? Because they're gonna be in the same scene. So if you're looking from the perspective of the enemy, when you do ... you're going up to the parent, which is node 2D. And then when you do /player, you're coming back down to the player. So the argument of the getNode, you can think of that as like how you specify file paths in your command line interpreter. So it's the same thing. So we're saying go to our parent and then go down to the player. So this will give us a reference to the player. Okay, and now this code you've seen again and again. So when you want to move something in your process method, first you come up with the speed in pixels per second, right? So we're going to say 80 for the enemy. And then you multiply that by delta to figure out how much you should move during this frame. This is how much we should move. Now, what I do next is I get a direction that I should move in. And my goal here is I want to move towards the player. So how do I get that direction? How do I get that vector? Well, I take the player's position and I subtract my position. That's going to give me an arrow, a vector that goes from me to the player. And by me here, I mean the enemy. And then I'm going to normalize that vector because we only care about its direction, right? We just want to get that direction. So we get that direction and we move the enemy in that direction, but multiplied by the move amount, because this is how much we want to move him in that direction. So just a little bit of redundancy, but this is a visual of what I just explained, right? So when you have two positions, so here we're kind of like assuming P2 is the enemy and P1 is P1 is the player, P2 is the enemy, something like that. So when we subtract P2 minus P1, we get this vector V. So when you do this minus that, you get this vector, a vector that goes towards it. So kind of remember this, this is how vector subtraction works. P2 minus P1 gives you the vector that goes from P1 to P2. So what we do is we take the player's position, subtract the enemy's position. That gives us a vector that goes from the enemy to the player. Then we normalize that vector and multiply it by our move amount, and when we move by that much. So hopefully that makes sense. All right, so let's go ahead and add an enemy to the scene and see if this actually works. So first I'm going to just add it manually right here. All right, so select in the main scene, select the root, press Control A. Well, no, not Control A. Press this little link button because we want to add a scene, not a node. So we want to add the enemy scene right over here, and let's name it enemy. And then let's go ahead and drag the enemy somewhere here. Okay, let's run this and see if the player actually gets chased by the enemy. So as you can see, the enemy keeps on following our player. Now the next thing that we want to do is when the enemy collides with the player, we want to keep on hurting the player. So let's introduce the concept of health. So for the player, open it up, open the script. Okay, now what we want to do is give it a health variable. Well, let me go ahead and type all of this code and then I'll explain to you what I've done. Okay, so what we've done for the player is give him a health variable. We've initialized it to 10. And then we made it a property where the getter just returns the health and the setter will set it first, and then if it's less than or equal to 0, then it's going to free the player, so delete it. Okay, so now what we want to do is when the enemy collides with the player, every second or so we want to keep on subtracting, I guess, let's say like 2 health or something like that from the player. So remember, how did we detect when a bullet collided with things? We made use of its area 2D. We're going to do a similar thing here. That's why if you look at the enemy scene, let's go ahead and open that up. You'll see that he has an area 2D. That's going to be used to detect collisions. Now remember, in the previous tutorial I said that area 2Ds can only detect collision with other area 2Ds or physics bodies. And the same is true of physics bodies. Physics bodies can only detect collision with other physics bodies or area 2Ds. So in order to do any kind of collision detection, you either have to be, an area 2D or a physics body. Now, let's go ahead and give the player an area 2D so we can detect collision between the player and the enemy. So for the player, let's rename this to sprite to stay consistent with our naming convention. And let's rename this to just player, the root node. All right, so for the player, in addition to a sprite, we're going to give him an area 2D. And let's give the area 2D a collision shape. And specify I guess we'll do circle shape for the player. And we're going to resize it just like that. So it encompasses the whole player graphic. Okay, so both our player and our enemy have an area 2D. Now, where do we want to handle this collision detection? In the enemy or the player? Well, this is arbitrary. To me, it just makes more sense to put it in the enemy. So let's go ahead and open the enemy. And what we want to do, first of all, is in the ready method of the enemy, so it's in its sort of constructor method, we want to connect, we want to listen to collisions that happen with its area 2D. So let me do that, and then I'll explain it. Okay, so here we've made one step towards our goal. What we have here in the ready method of the enemy, we get a reference to its area 2D. So again, this is the enemy scene, right? There's the root node 2D. Our script is attached to this root node. So all paths in this script are relative to this node. And what we say is we want to get area 2D node. All right, so we get a reference to our area 2D node. Then we connect to the area 2D's area entered signal, which remember that the area 2D will emit this signal when another area enters it. And here we're specifically interested in the player entering it. So we connect this signal to a method on this object, and the name of that method is onCollision. If you're not familiar with this name of operator in C#, this just takes an identifier, and then it returns the name of that identifier in a string. It's this way, when you refactor, when you rename this method, it'll be renamed here too. So that's why I like using the name of instead of just putting it in a string. Anyways, so in summary, the enemy has listened to its area 2D's area entered signal, and in response, it just prints out enemy detects collision. So let's see if this actually works. This is one step towards the right goal. So we're going to go back into the main scene and launch it. Let's go ahead and watch over here, okay? Watch the output. Let's see when he collides. Enemy detects collision. Okay. Step number 1 done. Now notice that I'm kind of doing this in steps, right? First I kind of leave stub code or printouts, and then I verify that those are working, and then I put in real responses. So instead of just printing this thing out, we want to actually do something. What do we want to do? Well, every second, let's make it simple. Every second we're going to subtract 1 health or 2 health. We'll subtract 2 health from the player. So first we need to get a reference to the player, right? So here we need to, well, let me write the code again, because I feel like if you watch me type, it's kind of wasting your time. So let me write the code and then I'll explain it to you. Okay, so we've made it one step better here. Notice that this onCollision callback, right? That's going to be called when the enemy collides with anything, even when it collides with another enemy. But this argument here is going to tell you what he collided with, right? So here I'm checking if what the enemy collided with is the player. So let's dig into this check a little bit. So I get the thing that the enemy is colliding with, and then I get its parent, right? And I'm saying that if its parent is a player, then we know we've collided with the player. So let me show you over here, right? So here we have the enemy and the player both in the same scene, right? We know that the player has an area 2D child, right? And when the enemy collides with the player, this area 2D is really what the enemy's area 2D is colliding with. So you see how both the enemy and the player, they both have an area 2D. It's really their area 2Ds that are colliding with one another. So during that callback, right, we get our with argument is this. It gives us a reference to the player's area 2D. We get the parent of this and we cast it to player. If it casts to player, then we know we've collided with the player. Now you may ask yourself, when I mouse over this root node, right, it says the type is node 2D. That is true, but we also attached a script to this node, and the type of that script is player. So the type of a node is either its actual type or the type of the script that you have attached to it. So remember that. Okay, now this should make sense. So here we've detected that we collided with the player. Now what we could do is, something like player.health, and we could subtract 2. But this would be problematic, and let me tell you why. this on collision is really this is the slot or the callback for the area entered signal, right? The area entered signal only is emitted only once when the two things collide. It won't keep on emitting, right? So they collide, this gets emitted, and then it doesn't get emitted unless they uncollide, and then they collide again. So you get that? When they overlap, the signal gets emitted, and then you have to wait until they unoverlap, and then overlap again in order for the signal to be emitted. So we don't want to damage the player every time we overlap with it. What we want to do is, as long as we're overlapped with the player, we're going to keep on damaging him. So for that, we're going to use a timer, right? So as soon as we detect that we're overlapping, so here we know we're overlapping with the player, we've started to overlap, we want to start a timer that will continue to execute a function that will keep on damaging the player. So I don't think we've been through timers before, so let's go ahead and talk about timers really quick. A timer is a node in Godot. So you want to use a timer when you want to execute a method periodically, which is what we want to do here, right? We want to execute a method that will periodically harm the player. It's also used when you just want to execute a method a single time at some later time. So these two conditions. And here's kind of like the code for it. You set the timer's wait time. This is basically like how long until the timer goes off. And what I mean, when the timer goes off, it will emit a timeout signal. So a signal called timeout. And you connect a method to that timeout signal. So you can kind of think that when a timer goes off, that method keeps on getting executed every time the timer goes off. So you set the wait time, and here's optionally, you can set the one-shot Boolean property to true, which means that this timer will only go off once. By default, it's false. So if you want it repeating, if you want the timer to keep on repeating, then you leave this as false. So you have the timer, you set its wait time, then you connect to its timeout signal. So you connect some callback or slot to it, and then you start the timer. And now every 5 seconds, this callback will be called. So let's use that concept. So first of all, let's go ahead and add a timer to the enemy. So search for timer, and there it is. All right, so we got a timer. Now let's get a reference to this timer, and then let's start the timer when we collide with the player. So let me write that code and then I'll show you. Okay, so what we do is when we've collided with the player, we get a reference to our timer. This is the enemy's timer. And then we start the timer and we set the wait time to 1. So there's an optional parameter that you can pass to the start method, and that is setting the wait time. So here we set the wait time to 1 and then start the timer. Now in the ready method of the enemy, what I do is I get a reference to the timer and I connect its timeout signal to this on timer timeout method, which is here. So this is executed every time this 1 second of the timer expires, right? Burped. Now what we do here is we get a reference to the player. Again, we go up 1 parent and then the player, and we subtract the player's health by 2. Remember that this is a property, and when the player detects that its health is below 0, it will free itself. Which reminds me, we want to check to make sure that the player is not null before subtracting its health. So we'll do if player does not equal null. So if he has not been destroyed yet. So there we go. All right, let's go through this one more time so that it makes sense. Now the enemy has a timer, right? And we, in the constructor, in the ready method of the enemy, we get a reference to that timer using the getNode method. We connect that timer's timeout signal to this function over here. Remember that a timer's timeout signal is emitted every time, its time value expires. And then what we do when we collide, right? When we collide with the player, so we know that this on collision method is executed when the enemy collides with the player, and we make sure that it is the player. We get a reference to the timer and we start the timer. So we've already connected the timer in the ready, and we start it when we collide with the player. And then what happens when the timer goes off? Every time it goes off, we damage the player. So kind of try to visualize this, right? The enemy, first of all, as soon as he collides with the player, he starts this timer. And the timer, every time it goes off, the player gets damaged. So now one thing we need to do is we need to know when to turn off this timer, right? Because every time the timer goes off, the player gets damaged. When the two things are no longer colliding, when the enemy and the player are no longer colliding, we want this timer to go off. So let me go ahead and do that. Now, we can do this easily by connecting to our area exited method. The area exited method, signal. The area exited signal is emitted when two areas leave contact with one another. So let me write that code really quick and then I'll explain it. Okay, so here we connect to our area exited signal. This is the function that we connect to it. Let's go see what that function does. We make sure that we're leaving the player, right? So we're no longer colliding with the player. If that's so, we get a reference to our timer, and then we stop the timer so that the player stops getting hurt. So in summary, when the enemy collides with the player, we turn this timer on. When they are no longer colliding, we turn this timer off. And remember that every time this timer gets executed, right, we're going to hurt the player. So this kind of makes sense, because as long as the enemy and the player are colliding, we want to hurt the player. So there's one other thing that I want to clean up a little bit. You notice that in this file, there are several times when I kind of use this somewhat long piece of code where I get a reference to our timer node. So I do it 3 times. You see, I do it here, and I do it here. Now what I want to do is go ahead and basically do this just once, maybe in the ready method, and save it off. So something like this. So let's give it a private field here. We're going to make it a timer, and we'll just call it timer. Right here, we're going to initialize it, and then we're going to keep on using it in the other places. So here we don't need to, get a reference to it again because we already did in the ready, and also here. So that's kind of, saves us, cleans things up a little bit, less code. All right, so we've written quite a bit of code, and I doubt this will work, but you know what? Let's see. Let's go ahead and run it, and let's see if it works. Let's make sure that we're at least printing something out every time we hurt the player. So we're gonna say right here, after we hurt the player a little bit, we're gonna do gd.print. So we're gonna print something. We're gonna say enemy hurt player. All right, let's see how this works. So we're in the main scene. Let's launch it. And this is probably not going to work because we added quite a bit of code, but let's see. So let's look at the output down here, okay? When they collide. Yeah, so, it is working. So every second we're hurting it. And then there we go. So we hurt it 2, 4, 6, 8, 10, and then we crashed because we deleted the player. We'll take care of the crash at some other point. I'm actually surprised that this worked on the first go because we added quite a bit of code. But hopefully you get that. So the main takeaway of this video is really the timers and how you can use them, right? Whenever you want to do something periodically or you want to do it once in the future, use a timer. So when you just want to do something once in the future, you can set the one-shot property of the timer to true. That way when you call start, the timer will only execute once. Here, since one shot is false, when you call start, the timer will keep on executing every second because we set it second. But if I put a 2 here, then every 2 seconds it would keep on executing. So I hope you kind of get the distinction between a one-shot timer and a repeating timer. Okay, that's it for this tutorial. Now, again, be sure to look at the link because I'm going to post the code. I'm also going to post slides, and the slides can kind of supplement or serve as a summary or a review for what you just learned. It can also be used as a kind of a reference. And I'll post any other relevant resources that I think might reinforce what we learned in this tutorial. So thanks for watching. Bye-bye.